Good morning. Well, we're going to continue on today with our development of our graphical user application, interface application. Um, this is being written on Linux, but this could be easily done on Windows or on Mac operating system, either one, any of them. So we will go down here to our Lazarus icon and bring up our, this will bring up our, where we were in our last application. We had written this window for entering user information. We have an add button. When we click it, we're going to write a record into the user's file. So with this screen, the intention is we're adding a new user. We're not changing an existing one or anything like that. So in the code, when you click add, let's go to the code now. This procedure executes. It's a button user add click, and we use the validation function that we wrote in our previous session, and it gets a status back, and if the status is a valid password, then we clear the status panel, and in this window the status panel is almost invisible, but it's down here at the bottom, and so if there was any text in there, it gets cleared. And then we have this blank spot, and it says this is where we're going to store. The code here is where we're going to store the new user password. Okay. Now the way we're going to do this is we're going to use block reads and writes to a disk file. That's different than writing text or something like that, because every record in a block type file is the exact same length. So the first thing I think we should do is we should define that record layout. And the way we're going to do that is we're going to create a new file, and it's going to be an include file. So let's see, we go over here in our toolbar and we click File, and there is a selection here called New with ellipses behind it. We'll click that, and it defaults to using text, which is, I think that's basically what we want to do here. So we will click OK for that. And now we get this text window, okay? And in this window, we're going to enter the, I guess you'd call it the record, the user record prototype. It's a type. We're going to define a type. And so let's start off by putting some comment lines in here, because this is actually Pascal code. But it's not a unit, okay, and it's not a form. It's going to be an include file. So in Pascal, we can use a comment by putting two slashes in, and then we will type in the name of this, that this file is going to have, and that's going to be user USR record REC dot, and then I'm going to say inc for include. Okay. Now, the next thing I'm just going to add some comments that explain what this is, so that when if you ever bring this code, print this code out and look at it, you'll instantly be able to see what it's for. So this is going to say this included code defines the user record type. Okay, throw a blank line, and then we will say the user record consists of the following fields. Okay. And now we will describe these fields. So we'll have a field description, right? And then space over here, and then we'll have the field name, and space over here, and we'll have the data type. I say okay, and I think what we'll do is up on this line we will say data, and on this line we will say type, that, and then we will say number of bytes. So up here we will say £, and then down here we will say bytes, like that. I think that'll work. And then we'll throw some dashes in here to delimit these. Okay, actually, you know what I could do up here? I could say field, couldn't I? Field name. So I'm going to go into insert mode by pressing the INS key, and I can now say field name, and it's not pushing things around, right? Okay, go back to insert mode by pressing the INS key, and I guess we can add a few more dashes here. Data type and the number of bytes, and that will do that line. Alrighty, so the first field is going to be what I call record status. We're going to use the first character in the block to indicate whether this record is active, deleted, hidden, whatever. It's going to be a character that gives record status. So I'm just going to say for field description, this is the user record status. And what's going to be the name of it? The name is USR stat. USR stat. Not state, stat. Okay. And it's a type character. Right. Let's go back and get that. Okay. And it is how many bytes? It's 1 byte. It's 1 byte. Okay. 1 character. Okay. The next field is going to be the full user name. So we just say user's full name, and that's called USR name. And if you recall, when we did the user add feature window, we set the maximum lengths of the fields. So let's just quickly go back and look at that. We'll bring that window up. So for username, and then we go over here and we look at the max length. The maximum length is 24. Let me get my cheaters on. I think it's 24. Yes, it's 24. And if we look at the next field, user ID, and we look at that max length, that's also 24, and it's the same for all these fields. The password's also 24, and the confirmation password is 24. So these are all 24 bytes long, 24 characters long. Okay, so let's go back into our text editor here, and where we're putting in this record definition. We're defining the record type, and so it's going to be the name is a type character, and it's 24 bytes, right? 24 characters. A byte is 8 bits. A character is 8 bits, so The difference between them is characters characters have a sign, so their range is from minus 127 to plus 127, something like that. So anyway, you've added that. The next field is going to be the actual user's ID. So that's user's identification, and we're going to call this user ID, and its characters, and it's 24 characters long. And I got to correct this. Got 2 R's in users. I got to push this over. There we go. Fixed it. All right. Okay, so the next thing we're going to store is not the password. The next thing we're storing is the MD5 hash, which is user ID for okay, let's say it this way, hash, and it's a user ID plus password. Okay, that makes sense. And we're going to call this user MD5. And we know that this is going to be an MD5 is 8 bytes, 16 characters, right? And actually, I think, yeah, we're going to have to change these lengths. I think we're going to have to change these lengths. Yeah. We're going to have to make this 25 because there's at the end of each field, we're going to have a null byte, because just like in C, the end of the string is marked with a null character, a 0. It's the same here in Pascal. When you're manipulating string fields, it will use that. It will use that sentinel null byte to determine the end of a string, or it can. And we're going to want that in this case. So an MD5 is, I think it's 64 bits. It's 64 bits, so it would be 7. If it's actually shown in hexadecimal, ASCII hexadecimal, that would take a total of 16 characters, plus the terminating null byte would make it 17. So that's what we're going to do here. Excuse me. And the last thing that we're going to have in this is the user's access code. Something we haven't talked about, but the user's access code is a character that indicates what levels of the menu are available to the user. So I'm going to just use one character for this, and we're just going to call this USR access. Oops. Okay, access. And it's a character, and it's one character. Now you notice that I don't make that 2 characters. I don't put a null byte sentinel on some of these fields that don't need it. Okay. All right. So now let's actually define this record. We've described it in our comments. Now it's time to create this record type. So we say type, okay, and then we put in the type, the name of the type. So this is going to be T user rec, okay, and then we say this is equal to a packed record. Oops, better make that right. Packed record. And now what we do is we list all these fields that we have up above, and we give them data types. So the first one is user stat, right? And its character. And the next thing is username, and it's an array 0 to 24. Oh, ellipses, right? Got to have ellipses. I think it's 0 to 24. Excuse me. Of character. So 0 to 23 is 24 characters, and the 24th character is actually the 25th character in this array. All right. The next is the user's ID. That will be stored in the clear. In other words, you'll be able to see it. If you were able to look into this file, you'll see the IDs, and that's also an array 0 to 24 of character. And instead of me typing these in manually, I probably should cheat and just copy the line above, but oh well. So the next thing is the user MD5. MD5, that stands for Message Dialogue Algorithm 5, right? And this is an array 0 to 16. Yeah, 0 to 16. That's a total of 17 characters. Okay, and that's of type character. Now we're not actually storing the MD5 dialog value. That would be a 64-bit unsigned integer, and I want these to. If you see them, you can. I mean, if you look at this file at the record, you should be able to see these actual values. Okay. And the last thing is the user's access. User access. It's kind of long, but oh well, whatever. And that's just going to be a single character right now. I think that's all we need. All right. And then we have to tell it that it's the end of the type. Okay. Now, we want to do a save as. So let's see, file, save as. And I want to say, I want to call this. So I'm going to say user rec.inc. I think this will work. Save it and see if it works. Yes. Okay, so now we have this record definition. Excellent. So we can include this anywhere we want in source code, in our Pascal source code. And of course, this is written in Pascal, a dialogue of Pascal. So this will work. It should compile. I guess we'll find out later when we actually add this in and try to use it. Okay, now the next step is we need to create a little, I guess you call it like a little library. We're going to create a unit that has the functions to deal with reading and writing block records, okay? And I've decided to do this kind of in a strange way. I've done this before in other actual applications I've written, and it seems to work really well, especially if it's an application where you don't have a lot of users banging on data all at the same time. And it also, you don't need index sequential access methods or run a SQL server or anything like that. I try to avoid those things because most small organizations, they're not going to hire an SQL specialist to manage their database. I mean, if it's an organization that only has 10 people in it, SQL is not necessarily a very good decision. So our files are going to be random access files, but there's not going to be any specific sorted order or a hierarchy or anything like that. So let's create a new unit. Now we're going to create a new unit kind of like we did the last time when we wrote password eval, right? We wrote this password eval unit. Well, we're going to basically do the same thing, except now we're going to write a unit that is specific for writing to block files. So up here in File, we click on, let's get it, okay, New Unit. And here we have our new unit. And we're going to call this unit we're going to call it lowercase u, R for random, file, IO, input output. Okay? And let's, we can go ahead and save as, I think. Yeah, let's do that. File, save as, and now we're gonna say, I gotta get my cheaters on here because I'm not seeing things too well this morning. Okay, this says U, R, file, IO already. But I don't like the way they're doing the capital A. So I'm going to say RF, delete, R file, IO. We'll see if it'll save the case. Okay, and then it comes back to our main program source code, and it says, it was unit 1, I want you to change it. So this is going to be unit R file IO. All right. So we've fixed that. This is in the myapplication.lpr file we're doing this, so I will save that. All right. And we've got user rec, and here's the new unit that we're now working on. Okay. And right after this, I'm going to put a comment line in, and it's going to say, we'll just steal from user rec inc. No, I guess we're not. I was going to say we could just steal the verbiage from this, but I don't think that's going to work. No. Okay. So we're back to our file io.pass. And we're just going to say this unit consists of a random block file input output functions. Okay, that defines what it is. And I mean, we could list the functions up here and describe them. Maybe we'll do that a little later. All right. Okay, now we've got this mode indicates that this is object Pascal. And here's where we're going to deal with, we want our records. We want records to be packed on byte boundaries. If we don't do that, then byte boundaries is not efficient, really, but it won't leave garbage laying in the records, because when you don't do it on byte boundaries, it starts inserting null padding in the records, and I don't like that, because if I do a file dump, I expect the records to be the size that I've defined them to be and not have any padding in them. So in all of your, probably in every source code file that does any reading or writing, you should probably say, you should probably add this comment. So this is actually a compiler directive, and here's what it says. It says pack records 1. So you say pack records 1. That's telling it to pack on a byte boundary. That's what that does. Okay. And here we have our uses clause, interface, and here's where we add our list of function prototypes that are used elsewhere to syntactically parse any reference that we make to any of these functions. So our first function is going to be our file create. And if I spelled create properly, that would be good. Okay. And the only parameter that we pass in this is a string, and it's the path file name of type string. And that's the end of that. And it is a Boolean function. In other words, it returns true or false. So it's Boolean. Okay. The next function, that's going to be, they all start with R file for random file. Okay. And this is going to be append. So this is going to add a record to the end of a file. Okay, so we got to pass it the path name again, right? So I'm going to copy that, Control C that, and then right here I'll Control V and enter it. And then the next thing we need is, okay, we're appending. I don't need a record pointer, do I? No. I need a pointer to the actual record we're going to be appending. So this is going to be, excuse me, we'll call this prec, and it's going to be type pointer. Okay. I'll wrap it down here on this next line. Excuse me. I've had this tickle for a long time. It's part of my mold allergies. And in the fall, when the leaves are falling and it's been raining out, the mold goes nuts outside, and I just cough all day long till my lungs are sore. So this is IREC, and this is going to be the size now. So we got the record pointer, and now we got the record size that we need. Okay. And this is just going to be an integer. Okay. We have to tell it how many bytes we're going to store. Yeah, we don't need that. Okay. And this is going to return a type of integer. It's going to return a code that indicates success or failure and what kind of failure. So that's why we have it as an integer. The next function, if we can append, then we should be able to read. All right. So we're going to have a read function, and we got to have that file name. And now we're going to have to give it what record we're reading. So IREC no is the record number, and we're passing that as an integer. And then we have to point to the buffer, just like we did up here, just like we did right here. We gave it the pointer to the buffer where the data is going to be. So we're going to have the same pointer here, the record. This is going to be the receiving buffer, okay? Record buffer, it's a pointer. And I think I'll put that down on the next line. Okay, something like that. Okay, it's a pointer. And then we need the record size again. So I will just come up here and shift in. I will control C. And I will control V. Control V. And there we go. So the record size again is an integer, just like it was up here in this line right here. And now this function also returns an integer. I'm going to space these out so they're a little easier to read. There we go. That helps. I'm always missing these cursor positioning keys on this keyboard. I've been using this computer for what, 2 years, and I still haven't got my keyboard layout figured out yet. Okay, so if we can append, read, create, we need to write. So this is a random write. So this would be used if you're changing a record, okay? If you're changing an existing record, then you'd use a random write. Okay, that's why we need this. So, and actually, everything that's here will work. Control C, down and Control V. All right, that's all the same. Yes. Okay, now we go down here below the implementation part, right? And now we're going to actually write these functions. So what I can do to save a little time, I can just take all this stuff, right? And copy it, Control C, come down here where implementation is, hit Control V, and now I have the start of all these functions. So, and there's no way I can mess this up this time. Well, I can mess it up, but it'll be a little more difficult. So the first function we're working on is create. And it is going to have this variable. Now, a block file has a handle to it. You have to open it. that sort of thing. So we're going to have, and that happens to be a type called T handle. Let's see, backspace here. Okay. So I'm going to have this file handle. We'll just call it F handle, and it's of type T handle. Simple enough. Okay, now we're going to begin our code. If we have a begin, we need an end. And excuse me, keep coughing and hacking here. So, we've the function is file create, and it's of type Boolean. So that's actually a Boolean value that we can return. So what I'm going to do is I'm going to assume that this is going to fail. So I'm right away, I'm going to set our file create equal to false. False indicating that it's a failure. It didn't create the file. Okay. So now we're going to need to check to see if this file already exists, because if the file already exists, there's no point in us doing any of this stuff. I'm going to say if the file doesn't exist, then we're going to do the stuff. So file not file exists, and then the name of the file is s path file name, right? If it doesn't exist, then we're going to do the stuff that follows. All right? So the first thing we're going to do is we're going to do the file create. Now, the file create is actually a function available in sysutils. You know, the uses clause up here, and it has sysutils. Sysutils has a lot of these primitive functions already taken care of for you. So we're just going to take advantage of this existing function, and it is f handle, handle equals file create. This is a predefined function that's available with object Pascal, free Pascal, and now we're just going to give it lowercase s, path file name. Now you have to note something here. I am including the entire path to the file, but I don't think file create will create the path if it doesn't exist. So this could fail if you don't have already the directory created, okay? Just so you know that. Okay, now we have to do a test. The file handle gets set to the created opened file. Well, when we're creating a file, we're not writing anything to it, so we don't need that handle open. So, but if the create failed, if file create failed, it returns a handle with -1 in it. A good file handle is anything 0 and higher. So just so you know that. So at this point we need to test if f handle, which is of what? Type T handle. Does that equal a T handle, a T handle value of -1? You see what's going on there? All right. So if it failed, what are we going to do? Well, we've already set our file create value to false, indicating a failure. So the failure is already set in the value. So at this point, we just do an exit. We do an exit, and that returns the failure code. Now, if it did work, if it did open, we don't need the handle. I mean, we've created the file and it's opened the handle, but we don't need it. So we do a file close of f handle. And that immediately closes it, and we're done with that. And the next step is then, that's the end of this if, right? It's the end of the if. Oops, and I already have the end there. Go back, do this. Okay, that's the end of this if. So the next step is we return true now. So up here, I'll just steal as much of this as I can. Control C, come down here. Control V, right? And now this is going to return true. So in other words, if we got through all that, past that if, we've successfully created this file. All right? So that's the end of that function. We got our first function done. Let's move on to our next one. And let's see. We have to have a begin, right? Begin. If we have a begin, there must be an end. This function will also need a variable, right? And that variable is going to be the same one that we had before, I believe. File append it. Oh, it has a couple things, interesting things. Okay, this also use constants. How about that? Now, a constant is an identifier in your program, the value of which never changes. It remains constant. Okay? So in this one, we're going to have a mode. And you'll see how mode is used here in just a bit. And if I knew how to spell mode, that would help. Okay. All right. And mode is an integer. And now we have to give it the value. Now, FM stands for file mode. And then open write indicates the action that's going to be taken, plus FM. Now we're going to define how we're going to share this file. So we're going to say share deny write. Oops. So we're going to open it and we're going to deny write capability to any other process that may be running. In other words, there could be another user at a terminal and he's using this same function and he's trying to do a write. This won't allow it until this is finished. That's what that basically means. So we're going to open it with share deny write. Okay. Now the other thing we're going to have here is max tries. Now max tries is an integer, and it's equal to the number of times we're going to attempt to write this record before we give up. So in other words, max try. I should put an I in front of it to indicate it's an integer. I like to do that. Put a lowercase letter in the front to indicate the type that you're looking at. That's okay. Now, how many times are we going to try to write this record? So I'm going to say 10 times. Okay. All right. And those are the only constants we're going to need, I think. Now we're going to put in the variables that we're going to need. So we're going to need a file handle again. And as before, that's a type T handle. Okay. And we're going to need itries. Now itries is going to be an integer indicating the number of attempts that have been made to write this record. Okay. And okay. So the first thing I'm going to do is I'm going to put in an assumed return code. So as before, we're going to have, in this case, the function rFileAppend is an integer. It's defined as an integer right here. So I'm going to set rFileAppend, that value, I'm going to set that initially equal to a -1. So the theory here is if I return a 0 or positive integer, it was a successful operation. If I return a negative value, it was unsuccessful. And then that value will indicate the problem. So let's just off here to the side say what this means. We're assuming file creation failure. That's what this means. Okay. Now what does this do? So the next thing is we say if not rFile create pass file name then we're going to just exit, I think. Yes. Okay. All right. So that means that when you append data to a file, the file doesn't even have to exist. If it doesn't exist, it will create it first. Okay? So the act of appending a new record will create the file. And why don't we, in front of this, just say, let's say attempt to create. Okay, yeah. Create the file if it doesn't exist. Okay. All right. So what's the next thing we're going to do? I hate this. Okay. So the next thing we're going to do is we're going to attempt to open. So we're going to say attempt to open the file for exclusive write. Okay. And so we're going to say rFileAppend learn to spell append and -2. And we're assuming a file open failure. Okay. And what do? We set the number of tries equal to 0. And then we do a while. While I tries is less than I max tries, do begin. Okay. And now we will try to open the file. So we do f handle is equal to file open. And a file open is going to have the path and name to the file, right? And so that's a string path, file name. And this is where imode comes in. We have to tell it how we're going to open it. Okay? So here's where we tell it we're opening it to write, and we're denying writes to any other process. And if some other process already has it open for a write, this will fail. Now, how do we know that it failed? So now we have to have an if statement. So we say if f handle is equal to t handle value minus 1, it failed. So then we will then begin. If we have a begin, we must have an end. Okay, and we're going to sleep. Now this is a function available in the standard free Pascal library, and the value you pass to sleep is milliseconds. So we're going to sleep for half a second, which should be plenty of time for another operation to complete. Let's just comment here. We're using a magic number, and I would say occasionally you can use magic numbers. I've been using -1, now I'm using 500. You should, in a comment, tell it what that is. So this is, I'm just going to say wait 500 milliseconds. Half a second. Okay, like that. So we're going to wait 500 milliseconds. And then we're going to increment. That's what this function does. I tries. Okay. So each time it fails, it increments I tries. All right. And this n needs an else, so we can't have a semicolon there. We're going to have to say else. So the if is if the handle is bad, it didn't open successfully, then we do that little block up there, sleep, and then increment I tries. Otherwise, it did successfully open. So a little comment here would say open, no, say file open was successful. Okay? And if it was, what do? We break. We break out of the loop, right? We break. And that's the end of the while. And right here, if we want to make that end of, and we come up here and grab this, Control C, come down here, Control V. That marks the end of our while. Now we know what that's the end of. When your code gets long, sometimes these little hints can help out. So that's the end of the while. So now what we do is we test to see if we have the while ended, but it doesn't, we don't know if it was successful or not, because the number of tries could have hit our threshold of max tries, and we could be now unsuccessful. And so we need to test if we were. So now, immediately after the while, we say if, I'll say if f handle is equal to type t handle of a value minus 1, we have a failure, right? So then we would exit, right? We would exit. And we would exit with what value? We would exit with file append, assuming a file open failure, because it would be minus 2 at this point, right? So if it wasn't a failure, we can move on in our code and do the next step. So the next step is we're going to position to the end of the file, and we do that, and we'll see if that was successful, right? So we assume a failure value, which is minus 3. And minus 3 is assuming insertion seek failure. Oops. All right. And did I have an istat? We need a status up here. So right here, istat is an integer, because we're going to need a status. Yeah. Okay. So the status is going to be, so we're going to say istat, oops, learn to spell stat, okay, is equal to, this is another function, standard and available for doing file IO type stuff. File seek on f handle. Okay, and we're going to go to byte 0 offset from the end of the file. So we're going to position 0 bytes after the end of the file, so that we would say fs, that's for file seek, and it says from end. That's a predefined value, okay? So if I status is equal to, say if it's less than 0. If it's less than 0. So if we get a negative value back, then it failed. So we do a then begin. I think so. Yes, we do a then begin. And if we have a begin, must have an end. So if the status of the file seek was less than 0, then we want to close the file file close of f handle and exit. And when we exit, of course, file append will be -3, and that will indicate an insertion seek failure. All right. Now, that's the file position part. Then, if we're positioned correctly, we're going to write the record out. So let's, I want to say write the record at the current file position. That's the next step. We will assume a failure. So we will set file append integer equal to -4, and we're saying assuming a write failure, like that. And now we do the istat equal to, and this is a function available from the standard free Pascal library. It's file write. We pass it the handle to the file we're writing to, a pointer to the record that we're writing, and the size of the record. And I'm going to give that I'm going to promote that value to a long int. Okay. I think that's right, isn't it? We passed irec size in. I'll have to take a look at that, make sure that's right. Go up here. Yeah, irec size is the integer we passed in. Right. Okay, so we're back to that line. So we do the write. Now, the thing that file write returns is the number of bytes that were written. So what we would do is we test, say, if istat, stat is less than irec size, then there was an error. Then what we'll do is just exit. Did I do a file close after the write? Oh, let's do that. I got to do a file close. No matter what the status coming back is, when we're done writing, we're done. So what we'll do here is we'll do a file close and pass it the file handle, and it will close that file. Okay. Then we check to see if it was correct or not. And if it's less, then we will just exit, and that will be exiting with our file append set to -4, indicating a write failure, right? Otherwise, what we do is we're going to indicate that our file append is successful, and we do that by setting our file append equal to 0. 0 means success. Okay. And that's the end of the function. So at that point it'll just return. We don't need to say exit or anything. And well, we could say here end of, and we just say our file append. Okay. Right. Okay. Now we're on to the read function. And we do a begin. The begin has an end. And this is going to do a lot of the same things that append did. Not append. No, it's not going to do anything that it did. We're doing reading, not writing. I'm thinking of the R file write. So, we're doing R file read. And alrighty, so we're going to have an I mode. We're going to have a constant because we're going to have another one of those I modes, right? And that's an integer, and it's equal to, and that's file mode read, right? File mode open read, FM open read, not read, open read, and plus, and we're going to share deny none. So that's, so in other words, if I'm reading the file, I'm not changing it, therefore I don't put some kind of a lock on it to prevent somebody from also reading it or writing to it, okay? And that's all we need there. Now the variables, we need variables. So we're going to do vars. And we have 3. So we're going to have an F handle again, which is a type T handle. And we're going to have an I offset. Oops, yeah. And not 2 capital F's. Let's do it this way. Okay, here we go. And we're going to have an offset. So this is the position in the file that we're going to read from. And it's int 64. And we're also going to have an I state. And I have this set for int 64. I'm not sure why at this point. It's not state. Yeah, it is state. It isn't state, it's stat. I stat. Okay. Excuse me. All right, yeah. Okay, and we're going to assume a failure, so our file read is equal to -1. And what are we assuming? We're assuming the file doesn't exist. Assume file doesn't exist. Now, unlike a write, we're not going to create the file if we're reading it. If it doesn't exist, then we're not doing anything with it. Okay, so in this case, we do that same test. We say if not file exists, spath file name, then we're just going to exit. That's it. We're not going to create a file or anything. Okay. Now the next one is we're assuming file read is going to be set equal to -2, and we're assuming that the file open failed. File open failed for some reason. Okay. So we attempt to do the open here. F handle is equal to file open. And we're opening S path file name. And we're opening it in I mode, right? Now we test to see if the open was successful or not. So we say if f handle is equal to t handle, type of handle that is a value of -1, then it failed. So we will do an exit again. And now we have to get, so we've got the file open successfully. At this point, we need to calculate, so we need to calculate the byte offset for the specified record number. Okay. And what we do here, we assume this is going to fail again. So we set that to -3. And we assume seek failure. Assume record seek failure. Okay. So now we compute I offset is equal to int 64. We're casting to a large integer, and we use irec no, the record number, and we are multiplying that by int 64. We want really big integers so we can have giant files if we need to. And this is going to get, we're casting irec size to a very large integer. We're multiplying them. We end up with this offset. The next thing we need to do is we need to seek to that. So we do an istat is equal to, and this is a file seek, and we're seeking to f handle. This is the file we're looking into, and it's I offset, and this is a constant established by free Pascal, and it's called fs. This is for file seek from beginning. So it will seek that offset from the very beginning of the file in bytes. All right. Now, if it comes back with a negative number, it means that the seek failed. So we would say if istat is less than 0, then exit. So that means the seek failed. So the final thing we do is the read. So now we read the file at that offset. So read the file at the current position. Okay, that's what this is going to do, and we're going to get istat. I keep putting state in, don't I? Yeah. And this is a file read, a function available, standard library. And we're doing a read on this handle, file handle. And we're reading the value into the buffer pointed to by this record pointer, right? And how many bytes? Then we tell it how many. Like this. And now we Whether we have an error or not, we don't care. We're doing the file close immediately. So we do a file close of F handle like this. And now we test to see if the read passed or not. So we say if istat is less than 0, then exit. It failed, in other words. And then we have successful file read, and we set the R file value for read. R file read is equal to 0. In other words, it worked fine. That's the end of this function. All right. We have one more function to write, and then we're done. This is file write. Okay. So we're going to have a begin, and there's the end automatically put in. End. Okay, and now we're going to have constants again, and the constants, there's going to be an I mode, and there's also going to be integer. Okay, the integer is equal to fm open write plus, and then we're going to deny anybody from getting into this file. If we open it successfully, nobody else is going to be able to write to it, open to write to it. And then we also we're going to have to do retries. So if for some reason we can't open it for a write, we're going to retry multiple times. So we're going to have I max tries. Guess we should make that over here. There we go. And that's going to be equal to 10 times. Okay. And now we're going to have variables. Variables are going to be file handle again. We have to have a file handle. So, and that's going to be of type T handle. And then we have I offset, because we're going to have to compute the offset into the file where we're going to do the write. So that's going to be an integer. Oh, that's going to be int 64. I'm sorry. That's going to be int. It's a big number. Int 64. And we also are going to have I state stat. That's int 64. And then we got I tries. And that's just tires. I tires. No, tries. There we go. And that's just an integer. Okay. Alrighty. Okay. Now, this is the last function. Yay. So now we're going to assume a failure again for write. And it's -1. And what's that assuming? This is assuming a write. Oh, file doesn't exist. Assume file doesn't exist. Okay, and then we do the test to say if not file exists, s path file name. Okay. Then exit. Exit. Okay. So then we're gonna, if it does exist, we're gonna attempt to open it, right? So we're gonna attempt to open the file. And we're going to do that, and we're going to assume it fails. So we're going to put in the file right is equal to -2. And then we do a while I tries is less than I max tries. Do begin. And now we attempt to open the file, so we do f handle. Handle is equal to file open. And the file we're opening is spath file name. And it's in I mode. Okay. That. Now we test to see if we have a good file handle. So we say if file handle is equal to t handle with a value of -1. Okay, then exit. No, not exit. This is where we delay, and we're going to try again. So we do we're going to sleep for 500 milliseconds, and we're just going to say wait 500 milliseconds, and then we're going to increment I tries, not I tires, tries, and that's the end of that. So that's the end of that. So I got to do I have to do a begin if I'm going to have an end. So I got to put a begin in here. Okay. Otherwise, it did successfully open, and we can break, I believe, right? Yeah. Else break. Else break from the loop, and that's the end of that while. So as soon as we get out of the loop, we test to see if we have a bad handle. So at this point we say if f that's right, f handle equals t handle, the value of -1, then exit. And that would come back, that would then return that -2, indicating a failed open attempt. Otherwise, we're going to now we're going to calculate the byte offset into the file for the record number that's been specified. And we do that. We're going to assume right away that this seek thing, the seek offset into the file has failed, so it's going to be -3. All right, and now we're going to compute the I offset, which is set equal to the record number that's been given, int 64 for I rec no. Right? Yes, I think that's right. Yes, I rec knows the integer. All right. We're taking that times the times the record size, which is int being cast to a very big integer, I rec size. Okay. And now we do the seek. So we do this. That's going to be file seek again. And this works just like the file seek for the read that we did. And this is going to be the I offset. How many bytes we're going to seek, and then it's from the beginning of the file. So it's fs from beginning. Okay? Now we have to test status to see if the seek failed. So we say if, I don't need that, istat is less than 0, then exit. Seek failed. The next thing we're going to do is assume that the file write failed. So we're going to just say file write is equal to -4. Okay. And we're just going to say istat is equal to file write. This is a standard function in the library, fhandle. And this is going to be I offset. And this is going to be fs from beginning, isn't it? Oh, no. Oh, what am I doing here? No, this is prec pointer. So that's the buffer it's going to write from. What am I thinking? And then this is the length of the record it's going to write. So we just do a long int. And we say I rec size. That. Okay? And now we test to see, okay, and then we close the file right away. Whether we have an error or not, we don't care. We got to get the file closed. So we do a file close, and that's a file handle that we're closing. And then we test. We say if istat is less than the int64 cast of irec size, then we had a write failure. Oops. And we would just do an immediate exit. And our value will be set at -4. Otherwise, why don't we just say here in a comment that write the record. Okay. And then here we say file write successful. And here we just set random file write is set equal to 0. So we return a 0. We're done. That's all the functions we need to do our write to the user file. So probably be a good idea to compile and see if we get any errors, see if I have any typos in that. Let's save it, and now let's do a run. Let's just do a compile. Okay, So we got an error here. Too many parentheses. Okay. Save it. Let's compile it for errors. I didn't spell exists right. Okay, save it. Compile it. I put a space in the wrong place. Okay. Save it. Compile it again. Get all the bugs clinked out of here. Yeah, I don't need that parenthesis. Okay. Right. Save it. Compile it. It's supposed to be tries, not tires. Okay, you can see how easy it is to find little typos, bugs like this. Doesn't take long. And let's do another compile, see if we get any more. Gotta left the word then out, didn't I? Okay, then exit. I think we got it. Yes. So, so this new unit, which is going to give us random file IO, is now, it's now ready to go. Okay. So back over here in users add, when you go to store a new user, one of the things you're going to have to check for is that there isn't a user with the same name already there. So that implies we're going to have to read any records that are in the file and determine if there's a user already there. Okay. So the next time we come back, we're going to stop for today because we spent a lot of time entering those file random file read-write functions. So when we come back, the next time, we're going to check that the file doesn't already have that user in it, because we're adding a new user. There shouldn't be a user name that's the same already there. So what we'll do is we'll read through any records that are in the file, if there are any, and search for an exact match on the name. That's what we'll do. All right, well, as usual, I'd like to say if you've enjoyed this content, you find it interesting or helpful, and you want to support what I'm doing, please click the like button, and if you're so inclined, subscribe. Thank you for watching, and have a nice day.